So let us apply the superposition theorem here and find out the voltage across the capacitor. We have two sources here. The superposition theorem can be applied when there are more than one source. So the condition is satisfied here. We have a voltage source and we have a current source. And when we look into these two sources, the frequency is different. So which is applicable for superposition theorem. So according to superposition theorem, only one source can be active at a time. So we'll make the current source to be active and we'll cancel the voltage source. The voltage source can be cancelled by short circuiting it. So when we short circuit it, this is our circuit diagram. So we want to find out, when we look back here, the inductor and capacitor are not in frequency domain. So we have to change that into frequency domain using the frequency here. So omega will be equal to 10 radian per second. So calculate the inductor and capacitor in frequency domain. So the formula for the inductor is j omega L, which will be equal to j into 10 into 1. So j 10 ohms. Similarly for your capacitor, 0.2 farad minus j by omega c, which is equal to minus j by 10 into 0.2 minus j 0.5 ohms. So accordingly their values are changed over here. So the entire circuit is in frequency domain. Now the voltage what we are going to find using the current source is V01. See here the current source, all these elements are connected in parallel, so we can apply the current division rule to find the current in this branch. Current will be taken as IC. So to apply the current division rule, let us reduce this resistor and the inductor. They are in parallel. So the resistor is parallel with J10 ohms. So when we find out, the value will be 4.878 plus J 3.902 ohms. So now redraw the circuit with this new impedance value, which will be parallel to the capacitor and our source. The source is 6 angle 0 degree. The current through this capacitor. So we are going to find this current through the capacitor. Thereby we are going to calculate the voltage across the capacitor. So the voltage across the capacitor will be equal to the current in the capacitor into the impedance value. It's impedance value minus j 0.5. So this is going to give you the voltage across the capacitor. So let us apply the current division rule. The current IC will be equal to the total current 6 angle 0 degree into, we have to use the opposite resistance. We want to find the current here, so we have to take the opposite impedance. The impedance value is 4.878 plus j 3.902 over all the impedance value. So 4.878 plus j 3.902 plus minus j 0.5 ohms. So if you do the calculation, then the current is 6.288 plus j 0.413. So our aim is to calculate the voltage across voltage across the capacitor. So the voltage V01 will be equal to the current IC into minus J 0.5. Therefore, when you multiply, the solution is 0.2068 minus J 3.144. So we have to give the voltage value in a polar form. So the polar form is 3.151, angle is minus 86.23 degree volt. So thus we have calculated the voltage across the capacitor by having the current sources active. So now we have to make the voltage source active. So if the voltage source is active means then the current sources will be cancelled by open circuiting it. So we are going to open circuit the current source and we'll redraw the, so the redrawn circuit diagram will be this way. The voltage source is active. So here for the voltage source, the omega value is 5 radian per second. So we have to recalculate again the inductor values and the capacitor values in terms of frequency domain. So 1 Henry will be J omega L, which is equal to J 5 ohms. And same thing for your capacitor, 0.2 farad is minus J by omega C, which is equal to minus J 1 ohm. So where these values are replaced, now our complete circuit is in frequency domain, so we are going to apply the rule over here. So we want to find out the voltage across the capacitor. Here we have a voltage source and these capacitor and inductor are connected in parallel. So in parallel the voltage will be same. So we are going to reduce these two and find out the voltage by voltage division rule. The capacitor minus J 1 ohm is parallel with your J 5 ohms. When we reduce that, it's minus J 1.25 ohms. So with this new value, redraw a circuit diagram. The voltage source, the resistor is there, the capacitor and the inductor are replaced by the equivalent value what we have just find out now. So this is our voltage source, 75 angle 0 degree, 8 ohms and minus J 1.25 ohms. So the voltage across this we want to find out by voltage division rule. So what's the voltage division rule? V02 will be equal to total voltage into the same impedance over sum of all the impedance in that loop. So the voltage is 1.7874 minus J 11.439. We should write this in polar form, 11.578 angle minus 81.11 volt. So this is our V02. So what will be the total voltage V0? V0 will be equal to V01 plus V02. Remember that V01 when we calculated the source was in cosine and V02 when we calculated the source was in sine. So when we write it, the maximum value of V01 is 3.151 cosine 10t minus 86.23 degree plus, and our V02 is 11.578 sine 5t minus 81.11 degree. So this is the total voltage across our capacitor. Hope you understood how to calculate the voltage across this capacitor by superposition theorem. So if you have any doubts, Please post all your doubts in Padlet link which we have been uploaded in the Moodle. Thanks for watching this video.